We are going to do an important theorem of this chapter, theorems related to circle. Theorem 32. The perpendicular drawn to a chord which is not a diameter from the center of the circle bisects the chord. This is an important theorem. We have to give the proof of this theorem. Okay. So this is an important theorem. And you have to remember the proof. You have to do the proof also. So let us do it. Which is not a diameter from the, let us do a circle. Okay. Suppose this is a circle and let us draw a chord AB perpendicular drawn to a chord from the center of the circle. So we draw a perpendicular from the center of the circle, which is O, to this chord. We have to prove that this perpendicular bisects AB. That means, suppose it lands at D, then AD is equal to dB. Okay, this is what we have to prove. So we have this circle and OD is perpendicular on AB. So let us get the solution here. In the circle, let OD parallel to AB. Okay? Sorry, perpendicular to AB. Hence, angle ODA is equal to angle ODB. Change this one. So OD is perpendicular on AB. OD is perpendicular on AB. We have to prove AD is equal to BD. Same thing. This is what we have to prove. Okay, this one is equal to this one. Only then it will bisect AB at D. Let us join OA and OB. So we will join OA and we will join OB. Okay, so we get two triangles, this triangle and this triangle. In triangles, triangle AOD and triangle BOD. These two triangles. We have angle ODA is equal to angle ODB. Why? This angle is equal to this angle. Why? Because both the angles are 90 degrees. Okay, because it is perpendicular, so it creates 90-degree angles on both the sides. Reason is 90 degree. Then OD is common, right? OD is common, and OA is equal to OB. Why OA is equal to OB? OA is equal to OB. Why? Because they are radii of the same circle, right? This is a radius and this is also a radius. So radius is equal all the time of the same circle. So OA is equal to OB. Hence, by RHS congruency. What is that? RHS, right angle, hypotenuse, side congruency. Right angle is this angle, hypotenuse is this one, side is this one, this is equal to this one. Okay, right angle, hypotenuse and side congruency. One side equal, hypotenuse equal, and there is a common, there is the and we have angles which are right angles, 90 degree, right? So triangle AOD is congruent to triangle BOD. By this congruency, RHS, by this congruency, these two triangles are congruent. Hence, it follows this is equal to this one, this is common, this is right angle. So by this congruency, these two triangles are congruent. And since they are congruent, their corresponding sides are equal. Hence, AD is equal to BD. Reason? Corresponding sides. Okay? Hence, OD bisects AB. This perpendicular bisects AB. Proved. By the way, slight modification here. We have to prove OD bisects AB. And how we prove it? By proving that AD is equal to BD, where this is the point at which OD meets AB. So this theorem is important because you are sometimes in exam you are required to prove the theorem like this. And by the way, in your textbook, I think this theorem is proved through SAS congruency, not RHS. They have used SAS congruency, and I am using RHS congruency. use RHS always, not SAS. Okay, I think that is an error. Using SAS congruency is not applicable here. Here you should use RHS congruency, because there is a right angle and there is hypotenuse and there is a common side. It is not SAS congruency. Okay. So this theorem is important. You have to practice it, memorize it. In exam also, questions related to this theorem may be asked, and you may be asked to prove this theorem also. So prove it like this. So the converse of the theorem is that if any straight line passing through the center of a circle bisects any chord which is not a diameter, then the straight line will be perpendicular on that chord. Okay, so it is the converse of the previous theorem that we did. So the converse says that if a line segment drawn from the center of a circle bisects a chord which is not a diameter, then the line segment is perpendicular to the chord. So let us take the circle again. Okay, this is the center, suppose O, and we draw a chord AB, and we draw a line so that it bisects AD is equal to BD. Okay, this one is equal to this one, so it bisects the chord. This line is drawn from the center of the circle. Then we have to prove that this angle and this angle both are 90 degrees, because only then it will be perpendicular, right? So to prove OD is perpendicular on AB. So to prove that, first we join OA and OB. We say AB is a chord, OD is drawn from center so that it bisects the chord. OD bisects AB. AD is equal to BD. Hence, AD is equal to BD. We have to prove what? OD is perpendicular on AB. This line OD is perpendicular on AB. Okay. So we already got this one. AD is equal to BD. It is given because it bisects the chord. Let us join AO and BO. We have joined AO and BO. From triangle AOBD and triangle BOD, these two triangles, AD is equal to BD, it is given. because it bisects. OD is common. This side is common. OA is equal to OB. Why? Because they are radii of the same circle, right? OA is equal to OB, which means hence by SSS congruency, triangle AOD is congruent to triangle BOD. Right? SSS, side congruency. So if they are equal, then the two triangles are congruent. So this we have proved that these two triangles are congruent. AOD is equal to BOD. This triangle is congruent to this triangle. Hence, angle ADO is equal to angle BDO. This angle is equal to this angle. Why? Because they are corresponding angles of congruent triangles. These are two corresponding angles of congruent triangles. These two triangles are congruent. Hence ADO is equal to BDO. ADO, this angle is equal to BDO, this angle. But AB is a straight line. Right? AB is a straight line. And OD bisects it. It bisects. So OD bisects it. OD bisects it. So what does that mean? A straight line and OD is bisecting the straight lines, and these two angles are equal. So what does that mean? That the total angle here, let us look at the total angle. Total angle here is 180 degree, right? So if it bisects this angle and these angles are equal, so what will be each angle? 90 degree. Hence, angle ADO is angle BDO is hence twice we have angle ADO plus BDO is equal to 180 degree, right? AB is a straight line and ADO is equal to BDO. So we can write twice ADO is equal to 180 degree, which means ADO is 180 by 2, it is 90 degree. ADO is equal to BDO, which is equal to BDO. ADO is equal to 90 degree, which is equal to BDO. So ADO and BDO both are 90 degree. If that is the case, then OD must be perpendicular. Hence, OD is perpendicular to AB. And we have proved the converse of the theorem. So this is how we prove the converse. Okay. So the converse and the original theorem both are important for this chapter. Practice it, memorize it. There are a lot of questions from this chapter based on this theorem and the converse of this theorem. So you have to understand these two theorems properly, the theorem itself and its converse also. So understand the relation between these two theorems. And also remember the properties of circles that I talked about earlier. So those are also important. Their proof is not important, but you have to know the proof of the theorem and the converse of this theorem. Those are important. But the properties, you just have to remember the properties and their application in various real life problems.